Welcome to Build Up, the European Commission's portal for energy efficiency and renewable energy in buildings. Directly stemming from the Energy Performance of Buildings Directive, Build Up is the meeting place for everyone involved in making the European building and construction sector more energy efficient. Every month we focus on a topic that is key to making Europe's buildings as energy efficient as possible. Exploring that, you can find the latest content such as expert talks, webinars, case studies and more. From architects and engineers to academics and policy makers, we've got you covered. Build Up brings together thousands of registered members to reap the benefit of Europe's collective intelligence on all aspects of energy efficiency and renewable energy in buildings. The Build Up portal benefits from the expertise of our ambassadors. Drawn from industry and academia, the ambassadors bridge the gap between EU and national level and help shape our editorial content. Want to promote your work? Build Up disseminates your research, projects and events through a variety of channels. Become a member to exchange knowledge with your peers. You can disseminate tools and resources, share good practices, and consult open source publications. Join the discussion on social media and become part of the Build Up community, or subscribe to our newsletter to receive the latest news. However you participate, the Build Up portal is here to inspire, inform and connect. Build Up, the European portal for energy efficiency and renewable energy in buildings. Join the community for opportunities and updates.
Good morning and welcome to today's webinar. My name is Arantzazu Galán González and I am a member of the Build Up editorial team. It is a pleasure for Build Up to host today's webinar and workshop event entitled Innovating Energy Performance, a deep dive into the EPC RECAST project, brought to you by the EPC RECAST and Build Up. This online workshop is split into 4 main parts, during which the project specialists will delve into the role of the EPC RECAST project in contributing to sustainable and efficient buildings. Before we begin, we invite and encourage the audience to send us their questions or comments to the speakers throughout the session. To do so, please use the GoToWebinar question function. These questions or comments will be addressed at the end of the webinar. Finally, we would like to inform you that we have just launched the Build Up survey to make sure that your needs and expectations within our platform are satisfied. We kindly ask you to please submit your responses by 31st of May to ensure your voice is here. The agenda for today's webinar is composed of 4 sessions. We have a little change in these sessions, as we will see the presentation of Andrei Litiu at the end. So we will begin with the presentation of Dominique Cacavelli, presenting the whole concept of the EPC RECAST project and objectives pursued. Dominique is Development Director at the Centre Scientifique et Technique du Bâtiment. We will then see Olivier Greslou, responsible for research strategies at the Centre Scientifique et Technique du Bâtiment, that will talk to us about the innovative process and digital toolbox to support the implementation of a new generation of EPCs for residential buildings. In the third place, we will hear about burdens and opportunities of EPC RECAST approach validation in real pilots, examples by Graciano Salvalai, Associate Professor at Politecnico di Milano, and Sara Momi, Business Developer at R2M Solution. At the end, Andrei Litiu, Executive Director at EPB Center, will present us the next gen EPC cluster and the EPBD RECAST. We will, after the 4 presentations, we will have some time at the end for a question and answer from the public, moderated by Build Up. And now, without further hesitation, we will move directly to the first session by Dominique Cacavelli, a Development Director at the Centre Scientifique et Technique du Bâtiment. Dominique, the floor is yours.
Thank you, thank you. Good morning, everybody. Just checking for my presentation. I don't see anything.
Yes, we need to show the presentation, Lara. There you go.
Can you see it?
Great. Well, okay. Let's start now.
Yes, we do, Lara.
Just
Yes, it's okay.
okay. Let's start. Well, it's very small, but trying to. Okay, let's start with this presentation of the EPC RECAST project. I will give you a very short insight concerning this research project. Well, this is very. I don't understand why it is so small. Is it possible to enlarge my presentation? To have it on?
It's full screen.
Oh, I don't think it's full screen, but okay. I'm trying to do my best because it's very small. Okay, so the EPC RECAST project is an EU Horizon 2020 program, and well, I'm really sorry, but I can't see anything about my presentation, so it's very difficult. How is it possible to have it smaller, to have it on full?
Dominic, at your
Yeah.
right-hand side, put it full screen in the panel control at your right-hand side.
Okay, I don't see it.
It's okay?
No, it's not okay.
No? You have to put it full screen in the control panel of GoToMeeting.
Okay, it doesn't care. I'm just checking my presentation on my side. Okay, let's start now. So concerning the EPC RECAST, it stands for Energy Performance Certificate RECAST. So it's a European project started in September 2020, and we are really close to the end of the project, as the project is finishing at the end of June 2024. So it has been founded under the societal challenge, secure, clean, and efficient energy, and the total cost is a little bit more than 2,700,000 euros, and the EU contribution is a little bit more than 2.5 million euros. The project is coordinated by the Centre Scientifique et Technique du Bâtiment in France. So let's now move to well, it's really challenging. It's really challenging because I don't see anything, but okay. Now, okay. Let's have some words about our teams. So altogether, the consortium is consisting of 11 partners. 4 partners belong to research centers, TSTB in France, Tecnalia in Spain, Fraunhofer IBP in Germany, and LIST in Luxembourg. We have also 1 academic partners, Politecnico di Milano. We have 2 energy provider in France, EDF and ENGIE, and finally 3 SMEs, Bimeo in France, NB in Slovakia, and R2M Solution in Italy, and we have a non-governmental organization, RIVA, in Belgium. Okay, so now let's have a word about concerning the EPC RECAST in a nutshell. The EPC RECAST project aims at developing and validating a new generation of EPCs for residential building based on innovation processes and building digitalization. We do not want to replace professional EPC assessors, but instead of to facilitate and improve their working practices to achieve improved EPC reliability, comparability between built-in assets, and user friendliness. We also want to generate an impact for building owners to engage them on a tangible pathway to an efficiency energy retrofit through tailored renovation recommendations. Okay, let's have, well, I'm just checking. Okay. So now let's give some words about the project objectives. Our main objective consists in supporting the work of EPC assessors to improve reliability of EPCs, and is based on, during all the process, EPC processes, data collection, quality checks, and model calibration. We also want to develop a full prototype of cloud system toolbox for EPC assessors. This cloud system toolbox will be presented later on. Finally, then we wanted to co-design the EPC assessment process with owners and assessors, and this will be done through interactive user-centered design approach. One of the objectives also to improve renovation recommendation in EPCs, and we have developed a renovation roadmap and additional indicators in the EPC certificate. Finally, the EPC EPC RECAST project have been tested. We are testing the next generation EPC on selected pilot buildings in 6 EU countries, namely France, Spain, Italy, Germany, Slovakia, and Luxembourg. We have developed training materials specially dedicated to EPC assessors. And finally, we have tried to collect recommendations from either public authorities and industrial stakeholders through advisory board and mayoral group. So now, what are the main EPC RECAST steps? The EPC RECAST process has been structured in 3 different steps. The first step is about the data collection and inspection process on site. And this process has been facilitated using smart technologies such as automated geometrical scan, drone, and infrared technology. This will be given a larger explanation later on. And this technology aims at enabling energy advisors to gain time and to be more accurate. Altogether, these first steps, the duration of this first step has been estimated to half a day. Then the second steps is when the energy advisor is coming back at his office or his or her office. Then the energy advisor has a range of tools and methods at her disposal to validate the overall consistency of collected data and to assess the building energy performance. Main issues of the diagnosis building are then identified. Then we have a third step based on in-depth understanding of the building's current situation. The energy advisor can then propose energy retrofit measure to improve energy efficiency and a renovation roadmap. An energy EPC RECAST energy performance certificate is then also generated that will increase the end user awareness. And energy performance and non-energy benefits such as thermal comfort, air quality, and CO2 emissions. So altogether, step 2 and 3, the duration of step 2 and 3 altogether are also about half a day. That means that when we combine the different steps, we can expect to have an EPC RECAST process duration of about 1 day maximum. And this is a real improvement regarding to the existing situation now. So let's now move to a very brief presentation of the for the cloud system toolbox. Of course, this toolbox will be presented will be much more presented later on by Olivier, but this is just a very first insight of this toolbox. We have four different elements consisting and participating in this toolbox. We have, as a first element, we have an EP assessment inputs, and the objective is to improve data collection. So we have developed different technology, such as the 3D building digitalization using BIMEO geometrical scan, and this is a quite new technologies that have been developed specifically for this project. We have also used, not developed by use, a drone and infrared technology to improve data collection. Then concerning the quality procedure, we have tried to develop reliable calculation methods based on dynamic energy simulation tools that are using ISO SEN standards based on the M480 mandate. We have also developed some processes to enrich and consolidate building data from available data sets and self-checking tests. Concerning the comparison with measured energy consumption, we have developed automatic calibration of building energy models from measured data, and we have also developed detailed evaluation strategy. Once again, all this toolbox will be presented by Olivier later on. And finally, we have improved renovation recommendation, developing a renovation roadmaps. I will conclude my presentation with some insight on concerning pilot activities. So the EPC RECAST toolbox has been tested on 55 pilot sites, consisting of 3 multifamily buildings as a whole, 40 apartments, and 12 single family houses. And these pilot sites were spread over the 6 participating countries. And these pilot tests have been used and have been tested by trained EPC assessors and project partners all along the project duration. At the same time, long-term monitoring has been implemented in about 50% of the pilot drillings. And finally, this is still a pending activity. Next generation EPCs will be delivered at dwelling or building scale. This is all for my presentation. Now I give floor to Olivier, who will give us some insight to the project results.
Thank you, Dominique. I will introduce into more details the technologies we have developed in the project and the overall integrated process that is at the heart of EPC RECAST. So I'm Olivier Grelou, I'm the coordinator of the EPC RECAST project, with more details now provided to our process. So just to recall the 3 EPC RECAST steps, so that because I will present each technology in front of each step, to say again what Dominique said is that we have this first on-site data collection and inspection process. It's a very hands-on project, because I mean it's a project that has been tailored to the needs of EPC assessors on-site. It's really focusing on the working practices of the assessors, and so we are trying to provide technologies that improve each step in the working process. Once again, the second step is the energy performance assessment. So it's mainly the energy simulation of the building back at the office with a dedicated software. And the third step, once again, is the certification process, where we provide the next generation EPC and an associated renovation roadmap. So just to explain, if we look at the standard process for an EPC assessor, we can see that there are several main steps. The first one is to collect, to take care about the standard conditions of climate and use of the building. Generally, these conditions are automatically integrated into dedicated simulation software. The input layer is where we collect data about the building fabrics, the energy systems in the building. So each EPC assessor does it his or her own way. Practices are very variable inside a country and from a country to another one. And there is no standard approach to collect information about the walls, about the windows, about the energy systems. So it's a very fragmented, process overall at EU scale. We have the evaluation layer where we need to use a standard national software. So in several countries, we have just one single calculation method. That's the case in France, so where you have different software interfaces related to the same computation core. In other countries, you have more software that can be used with different calculation approaches. But in the end, you need to use a software that is nationally approved by the state to issue the EPC to run the simulation, and then it issues the standard EPC in the specific country. So that's for the normal process. What do we do in EPC RECAST? We do it in 2 steps. So not on all pilots, but on the pilots where we have been able to test as many technologies as possible. What we do is first that we collect real conditions of use of the building. So we have the real climate that is measured, monitored from weather stations and from sensors that are located on site. We have this dedicated data collection process mainly based on the BMEO technology on iPad. And then we have an energy performance assessment simulation that is done with dynamic energy simulation models. Mainly 2 models are used in the project, the COMET one that has been developed for new buildings in France and the Energy Plus that maybe some of you know. What is interesting here is that we are using measured energy consumption to automatically calibrate this model to reduce the gap between the energy simulation and the energy consumption of the building. So this is why we are using real conditions to adjust the model and have a model that is calibrated so that then in the last step, we can issue the EPC. Once the model has been calibrated with real conditions of use, we go back to the standard conditions that are mandatory to issue an EPC. So we use again standard weather files that do not correspond to the location of the building or to the real use during a given year. So the standard weather files, the standard conditions of use of the way the heating system is used. But since the model has been calibrated based on the data collection and its algorithms, then we are able to issue an EPC that we think is more reliable than the standard national one. So now we issue this next generation EPC that has been developed in the project. To do that, we have developed, sorry, it's shifted a little bit fast. We have an integrated approach, digital one, based on what we call a common data environment, which means that we have standardized a data model of the building, which is based on the XML format, which is a given format for a data file. And this XML file is stored on an online cloud-based platform and is related, as you can see at the bottom of the screen, to different documents. So since it's standardized, you can store in this central data model information coming from pictures, from plans, from previous EPCs, from a BIM model of the building, from energy bills, and the information is stored inside the EPC. We are not using all the functionalities that could be developed with such an integrated scheme, but we have implemented the approach. And at the top of that, we have services. We use as different apps to collect information about the building, to do the post-processing and the evaluation when we do the simulation and the delivery. And so these different data files and services, which are digital apps, are all located on this platform, which is called Croquis, based on the French architecture, digital architecture, where we have a data file management system and we have different apps that you can launch as you would do on an iPhone or on a smartphone or a tablet from this online service. So if we look now at the core technologies, so I explained again the process. So you have this common data environment where you're storing files, and we have these digital apps. So first, for the on-site diagnosis, we use a technology that is based on an iPad to do the on-site visit. We are doing also on-site measurements of the building fabrics, mainly to get the heat transfer coefficient of the walls, storing that in our data model and files, from which we have algorithms that convert the information and that run this dynamic energy simulation, because at this small time step, that is the holy time step of the dynamic energy simulation, we can better evaluate novel energy systems like heat pumps, PV panels on the roof, and have a better representation of the heat balance in the building and the inertia phenomenon in the building envelope. So that also improves the accuracy of the energy simulation. In parallel, Tecnalia has developed in the project an automated model calibration process based on consumption data. As a proof of concept, it has been developed with another simulation core, which is the Energy Plus one. All of this could be done normally on the same simulation core, but here in the project, it has been done in two different simulation cores based on the technologies of the partners. And the parameters of the model calibration are fed back into the COMET simulation, which helps us in the end deliver the EPC certificate. What is interesting is that we are using the same simulation core also to issue a renovation roadmap, which is the tool that is at the heart of a building renovation passport, so that we have renovation recommendations that we can store inside the EPC. So these files, the information we find in the different files in the EPC certificate and in the roadmap correspond. We have more details into the renovation roadmap, but this tool helps also better evaluate the building with the EPC. If I zoom into the technologies, so the core process is really relying on new data collection. The difficulties that EPC assessors face are that often the building dimensions are not accurately evaluated. So there is a big problem because it has an impact on the kilowatt hours per square meter and the heat transferred through the walls. We have a high variability of data collection practices and results, and uncertainties of the assessments of the thermal characteristics of the building envelope. So our major contributions, as I said already, we have these specific measurements on the right, the on-site diagnosis, but we have also questionnaires that have been developed by R2M to assess the normal practices of the EPC assessors to evaluate these different characteristics of the building. We have also tested an infrared diagnosis by drone for multifamily buildings to evaluate the discrepancy of performance between different flats. It cannot be used today by EPC assessors, but that's a process that could be used in several years in the assessment of big buildings. I will not present all technologies, but just to give you more insights about the inspection. So it has been developed by this SME company in France, Bimeo. You can see it being used here in this example with the iPad. So the idea is to locate the different walls inside the building, visiting the building quickly with the iPad. Then it generates automatically this beam model with accurate geometry and dimensions of the building. And we have also associated questionnaires where we help the assessor observe characteristics about the walls, the windows, the energy systems. The observations in themselves are not really an innovation, but all the process is centralized in this iPad app, which also helps streamline the process and spend more time inside the building collecting all the information. So this is really fast data collection. And what this company is also developing is an automated connection with energy simulation software. So we have tested this link with research simulation tools in the project, but the company is also developing links with real software that are being sold on the market. So you could have an integrated process with the data collection and the simulation. For the specific measurements, we have focused on the thermal characteristics of the envelope because they have a big impact on the simulation results. Generally, we lack technical documentation dating back to the construction to exactly know what are the materials and the products inside the wall. The visual observations are insufficient to characterize the composition of the walls and the thermal bridges, and it's not possible to take samples of wall materials, of course, to evaluate them. So in some countries, the assessor is using default values. For instance, we say that the building dates back to 1970, and based on that, there is a U value of the wall that is automatically evaluated, and which is generally wrong and leads to lower consumption values in the simulation. Or reference values can be based on typical walls and materials, but once again, the accuracy of these values do not exactly correspond to the real thermal characteristics of the building. So we measure the performance of the building envelope with infiltration rates and heat losses through dedicated equipment, which we see in the next slide. It's based on heat flux meters, which are installed on some parts of the wall. So first, a thermal camera is used to position the heat flux meter at the right place, because maybe you could have heterogeneous conditions of a given wall. So it helps position them at the right place. They must stay there installed for 7 days, but since the footprint of the sensor is small, it doesn't have a big impact on the households. So you could install them at a low price, leave them for a week, and come back to get the results. They're also associated to sensors to measure indoor and outdoor temperatures, and the measurement must be done when the difference between the inside and the outside of the building is greater than 10 degrees. So in winter period, when the weather is cold outside the building. It can also be done to evaluate the wall performance of a multi-family building with sampling. So you can see on the right picture that just some flats in these examples have been monitored with these sensors. And then with calculation principles, we get back to the total heat transfer coefficient of the whole building. So the cost is limited, and we think that this could be also used in the future in some audit or EPC assessment processes. Now, if I go to the energy performance assessment, just to provide a little more details about the process, we have this on-site data collection, as we said, with the Vimeo app. Cloud data storage, you can then output an ISC file of the building geometry, a CSV file that you can also fine-tune, adjust on the computer if you do not agree as an assessor with all the values that have been evaluated. And then this information is transferred to our standardized EPC data model, where we have all the information about the building. We have developed in the project, just to do our test, a web-based simulation interface. What is interesting is that we have implemented data conversion algorithms, because we have just a restricted set of information about the building when we do the on-site data collection. But when we do the dynamic energy simulation, we need more information because these tools are more detailed. So this is why we need to enrich with the default assumptions or dedicated algorithms the collected information to be able to run this dynamic simulation. So the principle is that we do not ask an EPC assessor to collect more information than what he or she does today. We do the conversion of this information with the algorithm, so that then we can run a more detailed simulation engine that would normally be used by other professionals doing energy consulting and big simulations of larger buildings with more details. If I zoom on the calibration of parameters, so it's a toolbox that has been implemented online. Just the principle, once again, is to reduce the gap between the energy simulation results and the measurements. What you can see at the bottom is that you can see values before the calibration for the U value of the walls, if you have not applied the previous method we saw, or the infiltration rate, or the solar characteristics of the windows. The set of algorithms are run, and then we get the values after calibration, which are normally closer to the reality of the building. So it's still an R&D tool. We are not certain that that will be used today by EPC assessors on the field, but since it can be simplified with a dedicated online interface, maybe that's something that could be used in several years by professionals. And in the end, about the certificates, what we see is that we have developed this next generation EPC templates. We have two parts at the gray part is before renovation, and the green one on the right side is after renovation, and could be based on dedicated simulations or a renovation roadmap. We have energy rating and CO2 emission. The scales does correspond also to the revision of the PBD. So the A rating corresponds to the ZEB level, and the lowest rating to the minimum energy performance standard that will be imposed by the revised EPBD. We have a thermal comfort score to analyze the thermal comfort of inoccupants in the building in winter, mid-season, and summertime. We have more details at the bottom about the energy costs and consumption per energy use, so heating, domestic hot water, lighting, etc., but also per type of energy, gas, electricity, etc. Then on the second page about the building envelope, we provide before and after renovation characteristic of the walls, of the infiltration rate, of the energy system, so that we have more details. We have measured also energy consumption. If you have smart meters installed in the building or long-term monitoring, you could then draw these graphs, recapping in a simplified way the domestic hot water and heating consumption of the building, and being able also to standardize it according to the local weather, so that you could find on the EPC the comparison between the measurements of energy consumption and the simulation rating. And at the bottom of the template, you have renovation recommendations that can be linked with the renovation roadmap I presented next slide. So this would be only a summary of renovation recommendations that would be provided by another tool. So this is my last slide. So how does our renovation roadmap looks like? We import the data from the EPC simulation, so the EPC data model I talked about, which provides us the energy model of the building. We select renovation works quickly among several generic options, changing the windows, insulating the walls by the outdoor or the indoor of the building, and get the feedbacks and warnings about the combination of actions. So for instance, if you insulate tightly a building, you need to also be aware that you would have less infiltration rate and ventilation, and that you should maybe improve the ventilation system of the building. So you will find that as a warning or a risk in the tool. Then the works can be split into several steps. If we want to do a renovation roadmap in 2, 3, or 4 steps. And we get simulation results for each step, and then the final renovation roadmap. So the idea of this tool is that it's quite simple, it's quick and fast. Based on a professional that could be an EPC assessor. So he could be able this way, to provide the normal EPC, but also to issue this roadmap with a fast evaluation of the building and provide it to the owner. So this is a test about the link between these two tools, which are becoming major tools in the EPBD revision. And now I'm leaving the floor to my colleagues, Graziano and Sarah, to present feedback from some of our pilot studies.
Yeah, thank you, Olivier. Thank you, Build Up, for hosting also this interesting webinar. We are very happy to share our, let's say, finding here to this European platform. So I'm Graziano Salvarai again. I'm from Politecnico di Milano, and I'm, let's say, wrap up some information regarding the validation example, since we are involved in the project in the demonstration and impact evaluation. Sorry, very fast. So I will recap some information even already discussed by my colleague, but then this is just for introduce the quantitative verification approach. So according to the methodology explained by Olivier, we want to test different phases of our approach and comparing the standard EPC procedure with the EPC RECAST new generation EPC procedure. And then we have these three, let's say, main course part where we make some validation. So first is climate and building use condition, and then we have data collection. The idea is to see how we are collecting data and prove that our methodology is, let's say, is somehow fast and more reliable and precise than the standard one, and then the calculation methods according to the different, let's say, tool. We developed together with the coordinator 8 evaluation strategies applied to all the pilots, and then we use the long-term monitoring for, let's say, compare the results we had from the simulation with the real long-term monitoring data. And then very fast on the different strategies, I'm not going to all, but then the idea is to use long-term monitoring from one hand to analyze our approach. So the EPC RECAST approach that is using real condition is using BMAO app, so the LiDAR-based technology already discussed and introduced by my colleague, and then the EPC RECAST, let's say, energy assessment tool based on Comet and Energy Plus, as you have heard before, and then even for populate the EPC RECAST APC with the different information we think very, very important for, of course, the certified, but then for the final user. Then we use the real measured data for checking. And then we have even other different evaluation strategies, but then we use some of them for check a specific, let's say, piece of our tool. In this case, for instance, we want to test our methodology of data collection, geometrical data collection with the standard one. So we engage the assessor, and then we share our, let's say, geometrical survey with them, and they share their, let's say, geometrical numerical data with us, and we try to make simulation with different input in order to see how this can impact, or how in a way we can be more precise than the real standard. That in some building we experience that in some building where the drawings are not available at all. We are talking about building that might be built in the 70 or even in the 50. That is not, it's not easy to have, let's say, the drawing, and so the geometrical survey by the standard assessor is made by hands, and somehow they can lose some information. So this, let's say, evaluation approach has been done in a lot of demo cases across Europe according to our goal of the project. We have 48 demonstrators with long-term monitoring across Europe. And then I'm focusing today a bit more on Italian pilots, since we work on our, let's say, building here, distributing all over Italy. We have 50 demos that has been involved in the project, different from building typology, time of construction, level of renovation, and then plant system technology and energy performance. Of course, the idea was to have a collection of buildings as much different as possible across Europe in order to check pros and cons of the approach and so on. And then among 15, we had 8 demonstrators with long-term monitoring. We have data from more than 1 year, collecting winter and summer season. And the idea was to, let's say, analyze and use this data for even collecting the EPC RECAST template with, let's say, the measured data. And then here a short recap of our buildings. If you see, this is for the different evaluation strategies in the different pilots. So we use the pilot as a demonstrator of what? Of the different, let's say, point of the whole process. The idea was to use some of the pilot to test, let's say, the data collection, the other one perhaps for testing the long-term monitoring, and the other one for testing the engine, the calculation tool, respect to the standard. So we mix a bit the different evaluation strategies, but then the idea was at the end to prove the overall concept. The long-term monitoring has been applied in half of the pilots, and the idea at the beginning of the project, we thought to a specific methodology in order to balance, of course, the effort, the cost, and the practicability. In some, our idea was to be as less, let's say, disruptive as possible. So the idea is to use plug-and-play soft tools for collecting energy. So in some pilot, we decide to apply some technology. In some other, we use the bills for analyzing the data the data needs for heating, cooling, domestic hot water, and even electricity. In some pilot, according to the overall project picture, we develop, according with the coordinator and the effort of all the partners, a sort of let's say monitoring data, low cost and plug and play monitoring data for collecting climate data from one side, because as you understood, the climate data should normalize first the real, and then the climate for simulation was very important for us in terms to compare the different results from let's say the standard EPC and the real one, and then the thermal energy and the electrical energy. We also decide to collect electrical energy to see how is the impact of these energy vectors in some building respect to other, in order to understand if we may have some contribution from our project in defining new indicators. Here are some example of, I don't want to go in, but then the measured data was based on hourly basis, so indoor and outdoor condition. That was the main and the core of the monitoring for, is again having the climate data representation, and then the heating, cooling, domestic hot water measured over the year. We have more than 1 year in some pilot, in some other 1 year, but then the idea was to really collect the real data collection, the real data, the real energy consumption for as a reference for our simulation results. Of course, we need also to aggregate the data. We had really a lot of data, and this was very helpful for the project. But then we had also to aggregate in order to compare at the end of the whole process, since we need to prove that what there is written in the certificate, that is aggregate data in terms of primary energy for heating, cooling, domestic hot water, with our energy consumption collected. In some case where we work with the bill, the disaggregation of data was not possible, and so we take from the bills the heating, and then we split the domestic hot water according to a sort of baseline of energy consumption of water during the summer season. But then even in this case, we try to come up with the overall energy consumption, try of course to tune and try to be very close to the real, close to the real energy consumption. And this was related to the long-term monitoring. And then we start with the on-site data collection. That was a very one of the core and the main aspect of the project. So we use our an app of our project partner Vimeo, and then in this phase we try the accuracy and the velocity of the data collection, and also the data enrichment. So as discussed before, the idea of this tool was to scan the building very fast, very precise, but then even enrich the information like quality of wall, quality of windows, and so on. And in this case, we use this, let's say, phase of data inspection for training the EPC assessor. So in the overall picture, we hire assessor in all the pilots in order to, let's say, prove that what we do as EPC RECAST, let's say, assessor, is similar to what the standard EPC assessor do in building. But then even train train them what we are doing in order to see even they, let's say, point of view, and analyze if perhaps they would use similar technology. But then this will be discussed by my colleague Sarah Momi in a few slides. And then you see here some picture. I want to go into detail, but then what we saw here is that even this is one of the output from let's say the assessor point of view. It's easy to collect the information, and there is no information missing in using this tool. So we have picture, we have information all together, and this is respecting our expectation of half day of data survey, and this was proved by our, let's say, pilot, in the activity done in our pilot. Here some screen on the data enrichment. So it was not only a question of let's say collecting information, but then even the geometric information, even the performance of the wall windows. So it was very easy flux of information. At the same time, I was scanning the geometry. I was even inputs, of course, according to the available information, the typology of wall, windows, the renovation of year, whatever, all the information we found fundamental for our project. And then, in the according to the overall picture of the data flow information shown by my colleague Olivier, there was, we test the automatically generation of XML. So according to the scan, according to the data enrichment, we move to the XML that is the input to our engine. And this was very, very fast created by the EPC RECAST tools for letting then the creation of the EPC RECAST APC. And then here we have some results of the, let's say, the monitoring in this case. And the monitoring up to now is looking to the difference between the monitoring and the EPC RECAST, the standard EPC. And here we found some discrepancies, but then this is also due to the use of the building. So in the top, you see the standard EPC calculation for total heating, cooling, and domestic hot water, and then in the lower part you see the long-term monitoring. And then if we analyze the energy consumption here, we saw that what we found from the monitoring was very lower, much more lower than was expected from the EPC assessor. And then I want to make some consideration here now, but then what we can say immediately here is that the use of building have a very high impact. We know who was the user here. They were very aware about, how to use building, how to save energy. And so this is why we had this kind of discrepancy. And then what is also interesting here, you see the electrical energy consumption with it's covering the 49% of the overall energy consumption. This building is full electrical one, so in some case the monitoring and calculate the electrical energy is very fundamental in building. This is another case. This is a building built in 1960 where we had even here a discrepancy, but then the discrepancy is due to the fact that in some buildings not the overall building is warm up, because there are some rooms that are not normally heated. And so what we saw from the monitoring one is it's in some case far from the real energy consumption. In this case, the domestic hot water, to be honest, was higher. What has been measured was higher than what expected. But then these are some examples regarding how we are using the long-term monitoring. What is missing here currently is to compare the results from the EPC RECAST APC, because we are still running simulation. So in the next future, in the next weeks, we will have also the third comparison that will be the standard EPC, the EPC RECAST APC, and then the monitoring, in order to have the whole picture of the process. Here, in this case, again, we have this discrepancy in these buildings. So we are collecting along the pilots all the energy consumption and see how is, let's say, the difference. And we also try to use this long-term monitoring to tune the simulation. So I want to conclude saying that we developed an interesting testing methods for quantitative assessment, and then the long-term monitoring defined was, let's say, affordable in terms of cost and in terms of installation, because the idea was to be really plug and play. And then when we are working in real building, that's very hard, because we need even to understand the needs of the users. And then the long-term monitoring is reliable for some of the parameters. In some cases, we found a difficulty in getting some information, detailed information, but then the overall picture is very interesting. And the idea is to, let's say, always implement this kind of data monitoring in all the building in order to see the energy consumption. And then rapidity and accuracy of the geometrical data collection, that's very fast and very reliable in terms of geometry. Of course, some training is needed in order to increase the velocity and the data quality. And then the fast geometrical data enrichment. Once we have the geometry adding data to the geometry is very easy and fast. And so that was also proven by the test with the standard EPC assessor. And then, of course, we are the next step, and what is under investigation, we are quite close to the end of this. We are testing the overall data calculation. So we will have very soon in the next days the EPC RECAST EPC data that is, let's say, the ending part of the overall process. So from the geometry to the translation of the XML to the data input into the tool, and then the EPC RECAST template creation. So we are very close to ending this part, and we will present very soon the results. With this, I'm closing, and I'm giving the floor to my colleague Sarah Moment for the qualitative assessment of this verification, let's say, activity.
Thank you very much. Thank you, Graziano, and thank you also to Seste Betty, to Dominique Olivier for this introduction to the project, and also to go into the details of our very nice approach, innovative approach we are testing, and we are going to finalize very soon in June. Okay, just some quick slides on the qualitative assessment. So together with the quantitative part, the project is very much focused on delivery a qualitative assessment, which means understanding which is the approach we are using and how much this is aligned with the expectation of both experts but also non-experts. When we talk about experts, we mean the assessors and the energy performance assessor of buildings, but also building assets manager. On the other side, we have the owners, the tenants, which might be not so much experts of energy performance certificates, and especially of digital tools we are implementing, we are using very much in this project. So for these reasons, we wanted to target a number of questions for each of the two audiences, and also improve these questionnaires, but also this conversation we have during the pilot validation, thanks to some pre-testing of the process done in some exemplary pilots. And this pretest happened in Italy and in Spain. And this very much happened to make the needed adjustments in order to understand really, from the qualitative point of view, the direction we are going. And then the questionnaires were given in English, but there were also the possibility, thanks to all the partners we have here, to translate it in the national languages. We used the Google Forms, and they were split in two. The first part was submitting during the on-site visits. So basically the assessor together with the tenants and together with the pilot responsible as a partner of the project were all together. And it was possible to have this conversation, this lively conversation among all the people. And the second questionnaires have been delivered after the energy performance certificates, according to the model of EPC RECAST and the renovation roadmap we have just seen before, thanks to my colleagues. So we wanted just to say on-site, but also to check on-site, but also after the delivery of the with the impressions for our audiences. And for example, some examples just today, in order for you to have a quick overview, the assessors were. One of the assessors was very impressed by this methodology. Of course, having a software and having a series of digital tools help a lot in order to collect data which are reliable and also in a faster, quicker way for the assessors in place, and also to having the automatic detection of all the spaces, and by the same time make it easier, the calculation of heat dispersion, other stuff, really facilitate the work of the assessors. At the same time, we are very clean, because today we're also talking about burden. So it's very clear for the consultant that this is a process that has to be improved in certain phases, like there are some issues still pending, but we're working on it together with our partners. And this is very clear, and also help us a lot in order to have a quite straightforward process in place. On the other side, another assessor told us that this really facilitated data collection a lot. It reduced also the time for preparing the visit. But what was most important for us was that using these tools attract a lot the curiosity and the attention of the owner tenants. So this was one of the basic focus on this project, involving really tenants and owners in the process, so that you can just establish a sort of long-term conversation also in the future in order to make them the real players for having the renovation roadmaps in the future based on the energy performance certificates according to EPC RECAST. And this has also increased a lot the awareness towards energy uses in buildings in general. It is also very much aligned with the European Commission targets towards sustainable buildings and the new targets for mitigating the CO2 emissions. Our conclusion for our challenge solution, but together with Polimi's, SDB teams and all partners, is that there is an overall high interest and acceptance of the methodology by the assessors involved in all the pilots. Owners are curious, interested in further applications. We are also delivering an energy performance certificate template, which is correct, but at the same time, easy to understand and more user-friendly for everybody, for citizens having a building. The next step is really closing the loop between the tenant's need for building renovation and having the energy performance certificate according to EPC RECAST as a really as a reliable basis for financial institutions, banks, etc., for granting money to the tenants and making available this famous renovation roadmap. Otherwise, we cannot involve in this. So, yeah, this was my last slide, and thank you very much for your attention. The floor is yours, Andrei. Thank you.
Yes, hello everybody. Almost time for lunch, but we still have one more presentation. I'll try to be as quick as possible. Sorry for the technical issues. So we are now back on track. So this should have been the overview to start with, let's say the context in which EPC RECAST has implemented its activities, because it's very close now to the exploitation phase. It will end in a few months. So happy if all stakeholders and member states will take note of everything that EPC RECAST colleagues have been able to accomplish. It has been a challenging road, but I think the results are quite impressive, what you have seen already. So I will close now with the overview. So this is the context that EPC RECAST finds itself in. I'm not sure if I have been passed controls. Let's see. Yes, so I think that's me moving. Yes, okay. So I'm wearing multiple hats. Today I'm wearing both the EPB Center hat and Riva hat, where I've been working now for quite a few years. You can find me on LinkedIn, so those of you that don't know me yet, let's connect and exchange and sync. So EPBD RECAST, this is the process we have been undergoing in the last years. As you can see, the whole thing started in 2021. EPC RECAST team has been involved from the very beginning and is still involved, and we are going to support as much as possible a swift implementation at national level. So you see this backdrop of the steps that have been made. So we are now finally after the adoption phase. It's still pending publishing in the official journal of the EU, but it has passed now the Parliament, the Council. Both institutions have adopted. And that will put member states in the position to have 24 months as usual. So by June 2026, they will need to have transposed the text at national level. We are expecting, as it has been the case in the past, so by early 2025, we are expecting official guidance documents or recommendations coming from the European Commission, specifically DG Energy. And you see a link here on this slide where you can find the previous recommendations that have been prepared for the 2018 review, the revised, so-called revised EPBD. Furthermore, together with our colleagues at BuildUp Portal and all other sister projects from the NextGen EPC cluster, about which I'll share a few details in the coming slides, we are doing everything we can to support the implementation, to be sure that all the meaningful work conducted in these projects is being leveraged as best as possible. And we are looking now with the BuildUp Portal colleagues specifically to create a dedicated section on the BuildUp Portal that will also embed, in addition to the official DGNR guidance, also guidance documents by EU level stakeholders, and of course, covering all the results from these projects, EPC RECAST and sister projects that have been working on this topic. And just to illustrate on this slide, I guess you have seen this. I'm always giving thanks to Pau Garcia-Udi from DGNR. So this is a slide that has been shown in many events. EPCs, that's why this project is centered on EPCs, are in a way linked to all the other policy instruments of the EPBD. It doesn't mean EPCs are the most important element, but it's an element that is binding everything else. So this illustration here on this slide, I think, explains itself. The NextGen EPC cluster, I've just mentioned it. So this is the community, the family of projects. As you can see, on the left side, those are the starting years. So EPC RECAST is already 4 years in the implementation. Some projects have already closed. And as a group, we have been united from the very beginning. So ever since we were 3 projects, the collaboration started and we only took it to new heights. And in EPC RECAST, we have dedicated special efforts to bring everything we do at cluster level to the right level of awareness and meaningfulness. In addition to the NextGen EPC cluster, it's important to mention also the SRI cluster, the Smart Readiness Indicator cluster, in which there is a specific focus on the Smart Readiness Indicator. But at the same time, all these projects are exploring how EPCs and SRI can be integrated. And this is a chunk of work that has also been done in EPC RECAST, and contribution to that debate is and ways to implement are available, of course, on our website. Just a few upcoming events, if you're not already aware. So you can already register, or at least save the date in your calendar. So 22nd of May, 23rd of May in Brussels. 2 events. On the 23rd of May is actually our final conference as EPC RECAST. And on the 11th of June, we have a policy session as part of the Sustainable Energy Week. So be sure to already register. The links are available. You will receive the slide deck after the event, so you can swiftly register if you haven't done so already. Then I try to, let's say, get more intimate and illustrate how the results of EPC RECAST are so meaningful and useful for the evolution of EPCs in the EPBD. I'll not read from the slide. You have there the first 3 versions of the EPBD, so 2002, 2010, 2018. Bear in mind that the 2018 review was just, I would say, an opening of specific elements of the EPBD, so it wasn't a full recast. That's why the name is revised EPBD. Whereas now in 2024, the full EPBD has been opened up. And as you can see there, there's a short list of key aspects that will bring EPCs to a new dimension. So there will be mandatory and recommended key performance indicators. The classes will be A to G. Only exception will be A+ for positive energy buildings. There will be a common template at EU level. Quality will receive much more attention to ensure the same level of ambition in all member states. And there will be an introduction of public databases. And in the countries that are very keen on keeping data privacy as tight as possible, this, I think, is a big development. But for policy making and actually supporting the energy transition, public databases are a prerequisite, at least in my opinion. I don't want to speak in anybody else's perspective. Another thing that's important to have in mind is how complex EPBD has become from its original version. So the initial text had 23 recitals, 17 articles, and 1 annex. And we are now, 22 years later, 84 recitals, but let's look at the articles, 38 articles, so more than double, and 10 annexes. So the point I want to make with this, here you have the list of all the, I would say, juicy articles, just to have as an overview after the event. I'm sure many of you already have done this exercise. Also the annexes, and last but not least, you have this italic, the administrative articles and annexes, but still good to keep in mind. And this evolution, for me, I find it outstanding and commendable because building performance, and I guess we are finally there, needs to be acknowledged as a complex and ongoing process. So it's not something you simplify for the sake of keeping the administrative processes simple, because what do you get then as an outcome? And it's not something you do once and then you forget about it. And with the current EPBD, this is exactly like that, acknowledged. So buildings at assessment level, design, installation, commissioning, certification in this process, and then the lifetime of the building, the operational, the management part, now are all covered. And EPC RECAST has done quite a lot on this. And it's important that this is happening and is acknowledged, because otherwise EPCs and all the other policy instruments would just be looked at as administrative burdens, whereas there is technology, both hardware and software, that can support this complex process, which is building performance. And when I say building performance, I mean all facets, not only energy, emissions, indoor environmental quality, and so on. And EPC RECAST, and of course the other sister projects, has been doing and will continue doing just this. So to support that this process is implemented like that, as it needs to be, no oversimplification, just leveraging technology, both hardware, software, in innovative ways to make the whole process faster, more effective, more qualitative, and so on, as my colleagues already demonstrated. So I will end to say that we are now in a much better position when EPC RECAST and of course sister projects are already entering the exploitation phase in supporting the twin green and digital energy transition in the building sector. I stop with this, and thank you very much to my dear colleagues, and also to Carlota at Riva for having organized this event, and of course the support at Build Up Portal, and for having invited me to deliver this overview. Thank you very much.
Thank you very much, Andrei. We have run a little bit out of time, but we are not going to finish without a few questions for all of you. We have one from audience. They say, is the APP for on-site data collection as easy that the homeowner could do the data collection with the EPC assessor connected remotely, for example, via video? I believe it could be for Grachan or Oliver.
Just
I don't know. Yeah, please, Olivier.
I didn't understand the full question. If you can just recall it or copy paste it in the chat section we have.
Yeah, what they ask is if the APP for the on-site data collection that you have shown is as easy so that the homeowner can connect with the EPC assessor remotely via video, for example, and send the data.
Ah, okay. No, it hasn't been designed this way. The tool for data collection is a standalone one, I mean a private one that's sold on an iPad. Still with the Croquis platform, that we have two, central digital tools to centralize information. We have more tools in the project, but we have two main tools to centralize information. So the first one is the one on the iPad, which we use to scan the building and to collect information when doing the visit. And the other one that we didn't present in many details is this Croquis architecture-based platform, which has several functionalities. It has like a Google Drive functionality where we can store and share documents. We have apps there, and we have also the possibility, to have how to say video chats with people. So it's possible that you could use it to have a conversation between the owner and the assessor, and then drag and drop files directly in this web service in the folder of the project, so that then the EPC assessor could get the files before visiting the building. So we haven't used it really this way in the project, but technically it's feasible.
Okay, we continue with the software, and some other member of our audience said, except for the Energy Plus, all the software presented in this presentation is not free.
Yes, I mean, we showed Energy Plus because the calibration toolbox developed by Technalia relies on Energy Plus. So it's an R&D tool. I mean, we do not foresee Energy Plus being used in an EPC assessment process, but that was for the demonstration side and proof of concept done in the project. The main idea in the project is to use a more advanced simulation tool than the ones we find today in EPC software. So a dynamic energy simulation tool with the Horley time step, more detailed models for energy systems and heat transfer and thermal inertia of the building. So what we did in the project is that we are providing the proof that it's possible to run such detailed simulation calls with a simplified data collection, because we are doing conversion of the information from the data collection to these detailed computing calls. So we are proving it's feasible for an EPC assessor, but then in the future, it would be up, to software providers to develop full integrated chains with different detailed software.
Okay, awesome. We change a little bit the direction, and there is a question that says, do you have any suggestions for someone starting in this EPC market? Where are the opportunities to become an EPC assessor?
Well, that's a very broad question. Maybe, Sarah, I don't know if you want to answer.
Well, of course. Thank you very much. Well, the opportunity are plenty, especially in Europe. Then each country has its own rules. Of course, there is a degree at the university, a technical degree, and then depending on the rules in each country, there might be the chance to get a specific training, professional training recognized at national level. And of course, the training is on site, but also with lessons. I don't know if Graziano want to add something, or also Olivier on this. Yeah.
If I can say, I think the EPC assessor will be very important, even according to what Andrei said before. So EPC should be not an administrative, let's say, burden, but then should be, let's say, control even over the time. So I see a lot of opportunity there. Perhaps using even our approach, I don't know if we'll be fully ready and available for free, but then anyway, I see a lot of opportunity everywhere in Europe, since European Commission is really trusting on, let's say, energy saving on building first, and then using tools for reducing the energy consumption. So I see, again, a high room of, let's say, involvement there.
Yeah, we are in the period of skills, right? Since 2023. Skills are key to be able to reach our goals. So yes, please check to be energy assessor, and you can come from different perspectives, right? So you can be an engineer, you can be an architect. I mean, you can train yourself afterwards. So that will be the way to go. Let's go for an open question for all of you. Perhaps the most interesting one, I believe, that is, what are some potential future directions or expansions for the EPC RECAST project beyond this current scope? You all give a 360 vision, no, of the EPCs from the different optics. Where is EPC going, or the cluster of EPC going from now?
I mean, I can speak from the project perspective. What we work, as you saw, is that we work on this standardized scheme where we have this standard data model and platform that facilitates the connection between technologies. So the next step would be, for instance, to have a more improved integration of more technologies that could facilitate collection of data about the building during the on-site visit and before running the simulation, and also having more connections between professional software and this data collection, thanks to the standardization of data and the data model to facilitate an integrated process. So since it's a very modular process and it's based on standardization of digital processes, I mean, we could, go for more integration now that we have done the proof of concept, in the project, and also develop some professional tools like the one on the iPad. So from research and market perspective, that's one of the potential follow-ups of the project.
Mm-hmm.
In terms of, I can let my colleagues also answer, and then in terms of cluster, I would leave the floor to Andrei.
Yes, of course. Thank you, Olivier. This cluster has been very organic and has been a breeding ground to take things further. So this mantra of avoiding to reinvent the wheel has been really taken up, and EPC RECAST has further built on previous results from other activities. So that's a role model behavior. So congrats, guys. And this is being taken further. I can just share a few aspects. There are 3 projects that started last autumn, and these are coordination and support actions. They are part of the LIFE program, Clean Energy Transition track, and each of them will enable what has been done to be taken even further. So there is EPB. They look at an integrated approach when it comes to building performance assessment, certification, and management, because in reality, the people that are actually benefiting from having these insights and take better decisions and being triggered to improve their building performance, they don't care of all the namings, building renovation passport, EPC, SRI, all that. They just want somebody to coach them through this process and have the insights to take the right decisions, right? And be even nudged to a certain extent. There's another project, Smarter EPC, and there they are creating a sort of marketplace. They call it a hub. So that's a place. If you look at national level, there are many softwares available, or several softwares that EPC assessors can use. So this project is creating sort of like the EU level market for that, where any interested assessor from any market in Europe can tap in. So they could go there and have an overview of all the existing tools. And I assume EPC RECAST will be happy to be listed there as well. Because what's happening at EU level, that's why it's called Next Gen EPC, Next Gen. So we are a bit ahead. We are, I would say, even going further than the EPB, the current text that member states need to transpose in these projects. So any person, assessor at national level, they can offer additional services and they can make the whole process and experience so much more meaningful than just relying on the bare minimum from the legal context at national level. And there's a third project called Tunes. They are really looking at policy uptake. So ensuring that all the results stemming from this cluster of projects, EPC RECAST including, will be taken up in this upcoming 2 years of transposition and implementation. So this is the way forward. And I'm sure new projects will start this year and next year. So I would be happy to see an EPC RECAST that's also integrated in the most meaningful way, non-residential buildings, because it has this focus on residential to begin with. But that's my perspective. Thank you.
Thanks to you, Andrei. You have not gone further in the relation of EPC RECAST with SRI, and our audience is asking if you are taking it into account, and if not, if there will be a future goal.
We have taken the SRI is not at the core of the project, and we have other next generation EPC cluster projects where the link between SRI and EPC is stronger and is really the core content objective of the project. Still, what we are doing is that we have a colleagues like LIST in Luxembourg, who are very much involved in the SRI scheme, and doing at the same time, with a single visit of the building, an EPC assessment and an SRI assessment, and then just providing the SRI results on the EPC certificate. So the idea is to see whether it would be possible, I mean, to reduce the amount of time needed to visit the building to do an EPC and SRI if we do them at both at the same time. So this is what we mainly do in the project. So we try to see with the on-site visit of the building which are the question and the observations we have to make that we find in both the EPC process and the SRI process.
And the last question, and it's a pity because this is really animated, but it says, for which countries your software has the data model been developed?
I mean, the data model developed in the project is a generic one. It's not, then we implement conversion algorithms, but the conversion algorithms, I mean, have to be coded for a specific simulation, core simulation tool. So the XML data model in itself is not directly related to a software. It's just one way where we agreed between partners to represent and structure the information in a specific way and standardize one, common one. And then we would have to implement, I mean, to develop more algorithms to link it to other simulation software. So we proved that it's feasible, but then more work would be needed with, I mean, with software providers to work on the connection. But what is really important is that there is an initiative to work on the standardization of data files, I mean, for these evaluation processes for buildings, because this is what would facilitate these kind of connections.
Exactly, it's super interesting. In December of this year, BuildUp will treat the topic of data for a full month. It's key, right? Andrei, Dominique, Olivier, Graciano, Sara, thank you so much. I need to close here. We have taken a little bit more time because we have some technical problems at the beginning, and it was a really shame not to hear you answer the questions of the audience that is really animated. Thank you so much for a great webinar again. Thank you so much to our audience for attending today's webinar. A reminder that you will be able to find the recordings of today's sessions on the BuildUp portal and our YouTube channel in the coming days, together with the presentation slides. BuildUp has several webinar sessions already in the pipeline for May and June, so keep an eye on the BuildUp calendar and events on our social media for updates on this. Be sure to register on the BuildUp website to be able to share and disseminate your own content, and follow us on social media for updates. And finally, be sure to fill up the BuildUp survey by the 31st of May to make sure that your needs and expectations within our platform are satisfied. We wish you all a very pleasant end of your week. Thank you and goodbye. Thank you, everybody.
Thank
Bye-bye.
you. Thank you very much.
Thank you.
Thank you. Bye.
Bye. Have a nice day.
Bye.
Thank you. Bye-bye.